Greetings, everyone. Today we're going to quickly review some of the main topics from Unit 2, which is graphing linear equations, okay? So definitely have your notes. Again, this is not intended to be your overall general instruction. This is a quick review of the main topics. We've already done that in class, so this should go pretty quick. All right, determining if it's a function. So we had two ways that we reviewed that, right? So determining if let's say a table is a function. So we take a look at a bunch of x values and we have a bunch of y values. And we're looking for, are there any repeating x values? So this one would be yes, it is a function. I could also do something like this, where maybe I have a couple of repeats, and then maybe I have no repeats in the y values. This one would be not a function because we would say there are repeating x's, right? We can't have repeating x's. So if you were asked to explain, that's what I'm looking for. And then we also had from a graph, right? If I had a graph, let's say that looked like this, we would say that is a function, yes, because it would pass the vertical line test. So we have that in our notes, meaning it never touches a vertical line more than once. Okay? So what's an example of one that's not a function as a graph? That would look something like this. Okay? If I was to look here, I drew a vertical line, it touches at two spots. So this would be no, it fails the vertical line test. Okay, domain and range from a set of points. So again, if I gave you a table and we said that that relation was a function, okay, there's no repeating x's, that's good, that's our goal. And we wanted to state the domain and the range. There was three things we had to remember. First of all, squiggly brackets, okay? Then we list in numerical order from least to greatest, okay? And then the third thing we had to remember was no repeats. So on my range, my outputs, or my y values, we would only say 1, 2, 3, and close with a squiggly bracket, right? So squiggly brackets, numerical order, and no repeats. All right, let's create a graph from a table. So very commonly, we were given equations in standard form. And when we were given that equation in standard form, let's say, I'm going to do say 6, okay? The first thing we had to do, step 1, is to isolate the y. We end up with 3y equals negative 2x plus 6. I'm going to divide everything by 3. So my equation is negative 2/3 x plus 2. So now in my table, I'm going to use or choose x values. Typically, we choose the 5 values around the origin. And then I want to see your work, meaning I need to plug x into my x value in for x is what I'm doing there, right? So you'll notice I have parentheses where the x would be, right? That helps you guys with the sign work that we might encounter. So notice you don't even have to fill it in right away. Maybe just set it up and then fill in your given x values, okay? And then calculate. Well, negative 2/3 times negative 2, you guys, would actually be 4/3. 4/3 plus 2 would actually be, let's see, 4/3 would be 1 1/3, so I'd end up with 3 1/3. On a test, I won't give you anything that specific, okay? You'll probably end up with pretty easy whole numbers to work with. Here I've got 2/3 plus 2, would be 2 2/3. Here I'd have 0 plus 2, which is 0, plus 2, which would be 2. Negative 2/3 times 1 is itself. Negative 2/3 plus 2 would be 1 1/3. Okay, and don't worry about these third calculations. That'll be easier for you. Negative 2/3 times 2 would be negative 1 1/3 plus 2 would be 2/3. Okay. What matters is this should look like a line, right? This is the equation of a line. So it should work out nice and simple. -2, 3 1/3, so 3 and a little bit, right? -1, 2, just almost 3, 0, 2, 1, 1 1/3, so 1 and a little bit, 2 2/3, which is almost 1. If I look, yeah, that worked out pretty nice. We've got a linear equation, connect, and add your arrows. So again, your 5 steps. Isolate the y. Step 2, use or choose your x values. Step 3, substitute them in. Step 4, evaluate. And step 5 is to graph. Those steps are in your notes or check Google Classroom. Evaluate function notation. So here I would give you a bunch of functions. Let's have f of x. Let's have g of x. Let's have h of x. Let's have, let's do a random m of x. Why not? Okay. Then I'm going to give you a function. So let's say I say g of -2. First, choose the g function. Wherever there's an x, I'm going to put parentheses. And wherever there's an x, I'm going to plug in a -2. So I end up with a -4 plus 3, which would be -1. So g of -2 equals -1. So our 3 steps we talked about in our notes. Are you choosing the correct letter function? Are you plugging in the correct value? And are you evaluating? That's how that breakdown is. Let's do one more. Let's say I tell you m of -2. All right, that means I got to choose my m function. Wherever there's an x, I'm going to put parentheses. Wherever that x is, I'm plugging in -2. Well, squared means it's times itself. That would look like this. -2 times -2 is 4. +4 plus 1 gets me to 5. So m of -2 equals 5. All right, rate of change. Rate of change from a graph, from a table, points, and from an equation. Let's talk about from a table or a set of points first. So if I give you a bunch of x, y values, let's say -3, 3, let's say 0. I think of some better ones here. I'm just going to make some up, so it's not going to be linear in a sense. But I need you to pick 2 points to use and then use your equation, your formula for slope. Rise over run. Rise is y's, run is x's. Remember the pattern. If I choose, let's say 2 for my first y value, that means I would subtract my other y value. But if I chose 2 first, on the bottom, that means I have to choose -2 first. -2 subtract my other x value, which is -3. 2 minus 3 is -1. What's a double negative become? Positive. So we end up with +1 on bottom. -1 divided by 1 is -1. Okay? Don't forget m equals -1. So that takes care of from a table or from points. All right? From a graph. From a graph, you guys, all you have to do is count. Okay? I don't need to see anything, any work. You're just going to count. I'm going to make a quick little graph here. The slope. So this slope I know is going to be positive. And if I count, I'm rising 1, 2, 1, 2, and I'm running 1. So that'd be 2 over 1. See, double check again. Rise 1, 2, run 1. Still 2 over 1. So my slope is 2. All you have to do is count. Make sure your signs match. If it's going up, it should be positive. If it's going down, it should be negative. Okay, but we don't only have diagonal lines from a graph, we also have horizontal or vertical lines. If I have a vertical line, what's my slope? always undefined. Okay? I can't walk straight up a line. That's not okay. So I have a special word. So I go to horizontal line. Horizontal line, yeah, I could walk, but I'm not going up or down. So horizontal line slope is always 0. That comes down to understanding the idea of it, or you just have to memorize it. Okay, you got to pick which way you learn best and stick to that. Then from an equation, all right, I'm going to use a very similar standard form of an equation. I have no idea what my slope is, but if I solve for y, that'll probably help. So I'm going to subtract 2x from both sides. I'm going to divide everything by 3, which means the coefficient of x is your slope. So I would say m equals negative 2/3. Whatever number's in front of the x is your slope. All right, if you need more help on this, check your notes. See the Sabre Center. You've got everything you need to keep working on this topic. All right, graphing from slope-intercept form. Okay, so again, if I asked you to graph this same line, I need to isolate the y first, so I'm going to subtract 2x from both sides. I'm going to divide everything by 3. Okay, now I can graph. My slope is negative 2/3 because that's the number in front of my x. And my y-intercept is going to be 0, 2 because my b value is 2, but we always have to write it as a point. So if I plot 0, 2, I'm right here on the graph. If I count my slope, down 2, right 3, down 2, right 3, keep going, go the other direction, up 2, left 3. Okay, so you need to know that slope and that y-intercept to graph your line. All right, translated form. Translated form, let's say I've got something like this. Okay, first step is to still isolate the y. I'm going to add 2 over. Okay, now I need to identify some key features. First thing, my slope is always the coefficient in front of x. So m equals 1/2. Then I need to identify my starting point. My starting point comes from these two values. But remember that rule that we think of this as the opposite sign. So my starting point is actually negative 5, 2. So negative 5, 2 would be left 5 up 2. There's my starting point. Then I got to count my slope. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Okay, so I need that in order to graph. Connect your line, add your arrows. Sorry, that's not very exact. Hopefully yours is better. Okay, so key thing, what's your slope? What's your starting point? Linear inequalities. All right, so let's say I give you, again, another translated form. Let's do one of those first. Let's say I've got negative x plus 3. First, I still need to isolate the y, so I'm going to add 1 to the other side. If I feel like I need a number in front here, let's put a 1, right? So that means my slope of this line is negative 1, and that means my starting point is going to be negative 3, 1. Okay, so let's graph that out. That means I'm going to start at negative 3, 1. I'm going to go down 1 over 1. Okay, but then you need to decide if it's solid or dashed. This one would be a solid line because it's or equals to. Okay, so solid line Then I need to determine my shading. Here's where I need to see your test point. I'm going to choose, you can choose any point, but I'm going to choose 0, 0. So if I plug 0 into my original inequality, 0 in for y and 0 in for x, I get -1 on the left, I get -3 on the right. Is -1 greater than -3? Yes. So that means my test point is true. So I want to shade on the side that is true. Okay. Remember, if it's in standard form, you just have to isolate the y. So again, if you have a line like this, same steps, difference is you have to isolate that y. So you'd have a -2x plus 9, you'd have a -2/3 x plus 3, you'd still graph, you'd still determine solid or dashed, and you'd still shade the same way. All right, quick review again of those horizontal and those vertical lines. If I say x equals 5, that means I go to 5 and I draw a vertical line through the x-axis. Vertical line slope is always undefined, you guys. I can't walk straight up a wall, so I need a special word for that, undefined. Your y-intercept, there is none. It doesn't cross the y-axis. Let's review y equals -2. Go to -2 on the y-axis and draw a horizontal line through the y-axis. Okay. What is my slope? Well, I can walk across horizontal line, but my slope is 0. My y-intercept exists at this dot. So my y-intercept will be 0, -2. Hey, so again, I told you this would be a quick skim through all of the topics. You have all the notes, you have everything posted in Google Classroom. You've had about 6 weeks on this unit. Provided you all the resources possible, so let me know if there's anything else I could send you a link or provide for you to help you study. So good luck. We'll see you next time.